Today we'll start the respiratory system. Respiratory system helps you to do what? Breathe. Inhale and expel the air. Why you need breathing? To get the oxygen, right? Very important. Why you need oxygen? What do you think? For metabolism, okay? Oxygen is required for what? Metabolism. Why you need metabolism? To produce ATP, energy, right? So you now understand oxygen is very important, right? For your body. Without ATP, no physiological process will work. Okay. So first, we'll see the parts of the respiratory system. Then we'll talk about the processes of respiration. There are 4 processes. 2 of them occur in the respiratory system. Other 2 occur in the cardiovascular system. There are 4 processes. Then we'll talk about the individual organs of the respiratory system. First, we'll talk about the nose, which is the uppermost organ or part of the respiratory system. Then we'll talk about the pharynx, larynx, trachea, bronchi, those are the structures, and the lungs. The last 2 organs are the lungs. Then we'll talk about a structure that is called the respiratory membrane. What is respiratory membrane? It is a membrane through which the gas exchange occurs. Just know that it is a membrane through which the gas exchange takes place. We'll see the structure of the respiratory membrane and how gas exchange occurs. Then we'll talk about the covering of the lung, that is called pleura. Pleura is the covering of the lung. You remember heart has pericardium, right? The covering. Similarly, your lungs have connective tissue coverings, pleura. Then we'll talk about the mechanisms of breathing or respiration. What causes inhalation and exhalation of air. And then we'll talk about a fluid that is called surfactant, a very important fluid in the lung. So the organs or parts, if you start from the top, nose, inside the nose you have the cavity that is called the nasal cavity, okay? And around the nasal cavity you have sinuses. You remember from NP1, maxillary sinuses, right? Frontal sinuses. So around the nasal cavity you have sinuses inside the bones. Pharynx. Next to the nose is the pharynx, which is a muscular tube formed by muscles. The next part is the larynx. Larynx is cartilaginous structure or tube. Pharynx is muscular, larynx is what? Cartilaginous. Okay? And after larynx, you have the trachea, which is cartilaginous and muscular. In the back part you have muscle, in the front you have cartilage. Is it clear? Then the lower end of trachea, this is the trachea, the lower end divides into 2 branches. So this is trachea, and these 2 branches are called primary or main bronchus. Okay, so this is right primary bronchus, this is left primary bronchus. If you see bronchus, that means one. If I say bronchi, CHI, that is plural. Okay, so this is right bronchus, this is left bronchus. So how many bronchi you have? Two. Okay, and they enter into the lung. Okay, and inside the lung, what happens? They branch again and again, like the trees, branches of the trees. Many branches, larger branches give smaller branches, and like that. Okay, called the bronchial tree. Makes sense? Bronchial tree. We'll see the name of those small divisions. Just know first that inside the lung you have bronchial what? Tree. Like the tree of, the branches of the tree. So many inside the lung. And then lungs are the last organs. And the lungs are filled with many tiny balls, air balls. Those are called alveoli. Million. In one lung, you have about 1.5 million alveoli. So now you can think how small air balls are those. So these are alveoli. Okay, alveolus again. Us is singular, alveolus, alveoli, plural. Some people say alveoli, that's also okay. Okay, so those are the parts of the respiratory system. Okay, so pharynx is what? What kind of tube? Muscular. Larynx is what? Cartilaginous, right? And trachea has cartilage as well as muscle. Okay. Now, inside the larynx, you have vocal cords. Vocal cords do what? Produce sound, right? Very important. So that's why larynx is also called voice box. Have you heard that? Larynx. Because inside it you have vocal cords. Trachea is also called windpipe or tube. Trachea, windpipe or tube. So those are the parts. Now, as I said, that inside the lung, the primary or main bronchi divide again and again, right, to form the tree. So what happens? Primary bronchi, this is the right primary bronchus, left primary bronchus, enter into the lung, and first they divide into secondary bronchi. The secondary bronchi divide again to form the tertiary bronchi, getting smaller and smaller, narrow. The tertiary bronchi divides into bronchioles, and then bronchioles branch again to form terminal bronchioles. When the bronchioles are formed, the diameter of a bronchiole is less than 1 millimeter diameter. And terminal bronchioles are even smaller, they are less than half millimeter diameter. So very narrow, you can think. But this is not the end. Okay? So primary bronchi enter into the lung, and then secondary bronchi, then tertiary bronchi, then bronchioles, then terminal bronchioles, right? Then from terminal bronchioles, we get, so this is the terminal bronchiole, terminal. Then from terminal bronchiole, we get further branches, respiratory bronchiole, okay? And then respiratory bronchiole becomes alveolar duct, So these are actually alveolar ducts. Okay, so these are alveolar ducts, and alveoli are attached to the alveolar duct like this. So these are the alveoli attached to the alveolar duct. Okay, so after terminal bronchiole, after this one, look at this, after this one, you have what? Respiratory bronchiole, make sense? Then alveolar ducts, and then alveoli, make sense? These three parts, last three parts, respiratory bronchiole, alveolar duct, and alveoli, are three structures where gas exchange occurs. Very important. Gas exchange occurs in these last three structures: respiratory bronchiole, alveolar duct, and alveoli. All other structures, that means all these structures are only to do what? Passage of gas, no exchange. They just only let the gas enter. Is it clear? Exchange occurs only in these three last structures. That's why these three parts belong to gas exchange zone, and everything before that, that means all these structures are for the passage of gas, called the conductive zone. So from here, all these belong to conductive zone because they are only for the passage of gas, not exchange. They belong to conductive zone. Only last three belong to gas exchange, also called respiratory zone. Okay, now we'll talk about the nose, the first organ of the respiratory system. Inside the nose, you have a cavity called the nasal cavity. Okay? External nose you can see from outside. This is called what? External nose. You can see. But inside it, you have a cavity, nasal cavity. Nasal cavity is divided by what? Septum, nasal septum, right? Partition that separates into two halves. Now, nose has some important functions. One is, inside the nose, you already know, always moisture, right? Inside the nose is moisture. So, when the gas enters into the lung, the gas passes through the nasal cavity, the surface is moist, so if the gas is very dry, the air is very dry, it will get a little bit moist. Make sense? And also, inside the nose, lot of blood flows in the wall of the nasal cavity. A lot of what? Blood flows. So the surface is warm because more blood means more warm. Okay. So when the gas passes through the nasal cavity, it gets warm as well as moist. Make sense? Because inside is moist and warm. The wall is warm because of plenty of blood circulation here. Filters and cleans inspired air. How the air is filtered? Inside the nose, you have two things. Inside the nose, you have hair, right? So big dust or big particles will be filtered by those hair. But small dust particles inside the nose, the surface is not only moist but also sticky surface, right? So tiny dust, that you don't see will get what? Attached to the sticky surface of the nasal cavity. Okay? So the air will get cleaned by those two things, here as well as sticky surface of the nasal cavity. Is it clear? Mucus. Serves as a resonating chamber for speech. You all know that nose plays important role in speech. If I close your nose, the sound, if you talk, someone can tell, right? Something is wrong. Your sound changes. When you get cold, right? Your sound changes. So nose and paranasal sinuses around the nose help to improve the quality of sound. Smell and taste. Again, if you don't smell the food, you don't taste it perfectly. You all know that, right? When you get cold, taste is not as good as, if you don't have cold. So we know that two things. Taste plus smell. Probably you know, together gives what? Flavor of food. The flavor, the actual taste, okay, that you enjoy is given by both, right? Tongue as well as nose. You know that, right? If you don't smell, then you don't enjoy the food. Okay. Okay. Now, nasal septum divides the nasal cavity into two halves. And inside the nose, you have concha, superior, middle, and inferior. Concha or concha, both are correct. And roof of the nasal cavity. Roof of the nasal cavity is formed by two bones, ethmoid and sphenoid. Floor of the nasal cavity. Actually, the floor of the nasal cavity, if you put your finger inside your mouth and move up, that is the, or with your tongue, you can touch the roof of the mouth, which is the floor of the nasal cavity. So here is the nasal cavity, this is the oral cavity or mouth, okay? So this is the palate. You know palate? Okay, so palate is separating nasal cavity and oral cavity. So that is the roof of the mouth or floor of the nasal cavity. So hard and soft palates. Okay? And respiratory mucosa is the innermost layer of the nasal cavity. Mucosa, innermost layer or lining. So here, this is a hemisection of nasal cavity. So you see one side. These are concha, superior, middle, inferior. And they are separated by these groups, you see. These are called meatases. Meatus. Superior meatus, middle meatus, inferior meatus. 3 concha, 3 meatus. And that is the roof of the nasal cavity. You see the cribriform plate of ethmoid. You already have seen in NP1. And this part is the sphenoid bone. So ethmoid in the front and sphenoid in the back. Now the floor of the nasal cavity, this is the hard part of the palate, bony part. This is the soft palate, skeletal muscle, remember. So if you see the palate, palate has hard bony part and soft muscle part. This is soft palate, and this part is hard palate. The anterior part, 2/3 part of hard palate is by maxilla. And posterior 1/3 hard part is formed by palatine bone. So these two bones form the hard palate. The front part is maxillary bone and back part is palatine bone. That's why it is called palatine bone. It forms the palate, part of the palate. Make sense? Palatine bone forms part of the palate. If you just think, look at me. Which bone is this? Maxilla, right? So the front part of palate is by this bone, maxilla, and back part is palatine bone. And soft palate has skeletal muscle inside. Remember, skeletal, not smooth. This is an exception because most of the internal organs of the body are smooth muscle, but this is skeletal. And the tip or free end of soft palate, this part is called uvula. Uvula, it's hanging like this. The end part is of soft palate is uvula. Now look at this picture. This is maxillary bone, this part, palatine bone, this part. That's the soft palate, skeletal muscle, and this is the uvula. Okay? Respiratory mucosa is the inner layer or lining of the nasal cavity. And this lining is what kind of epithelial tissue? Pseudo stratified ciliated columnar. How many of you remember from NP1? Pseudo stratified ciliated. Have hair like soft hair, right? Cilia. Why you need cilia in the upper respiratory tract? To move the mucus. You remember a few minutes ago I said that, air has dust in it, right? And the sticky surface or mucus traps those dust particles, right? Because the surface is sticky. But at the same time, that dirty mucus that gets dirty must be removed from there, right? Should not stay there for a long time. So the cilia beat like this. Make sense? Work like broom, the surface. Okay? Clean the mucus, dirty mucus. So new mucus will be secreted there. Okay? So that's why. So if you just think, that makes sense. What kind of lining should be there? Pseudo-stratified ciliated columnar epithelial line in the upper respiratory tract. Not only in the nasal cavity, but also in the larynx, trachea. In the respiratory mucosa, as I have already mentioned, you have plenty of blood flow. So the surface is warm. That makes the air slightly warmer. Inhaled air slightly warmer. And many sensory nerve endings are there. That's why inside the nose, you all know, is very sensitive, right? If you put something inside the nose, you will sneeze. That will trigger what? Sneeze. That happens. Highly sensitive, right? Inside the nose. If you smell something, you sneeze. If you smell some gasoline or something like, that irritates the, which is good or bad? Good, right? What do you think, everybody? Highly sensitive nasal cavity is good or bad? Good. That is a good protection, right? If something toxic tries to enter into your body through the nose, it will detect it, right? And sneeze, or you can feel that burning sensation, right? Will go to your brain. So, very important. Now, you remember at the very beginning today, I said there are 4 processes in respiration. How many? 4. First 2 take place in the respiratory system, and last 2 take place in the cardiovascular system, circulatory system. Okay? So what are those processes? First, pulmonary ventilation. Very simple. What is pulmonary ventilation? Breathing. Make sense? Breathing is also called pulmonary ventilation. When someone's breathing stops, then you do what? Artificial? You give what? Artificial ventilation, right? Ventilation means breathing, artificial breathing. Okay. That means inhale and exhale the air. Also called inspiration and expiration. Or inhalation, exhalation. All same, right? Taking the air in and pushing out. So that happens in the respiratory system, you all know. External respiration. What is this? After the air enters into the lung, inside the lung, gas exchange occurs. Inside the lung, what happens? Gas exchange between the lung and the blood. So, you remember inside the lung you have tiny air balls called what? Million. These are called alveoli. And on the surface of each alveolus, alveolus is singular. So if I just take one, this is the, I'm taking one alveolus to see, this is the alveolus. You have air inside, and on the surface of each alveolus you have capillary. So this is the capillary, okay? Blood capillary. So you have blood here. Makes sense, right? Inside the capillary you have blood. This is beautiful something. You have million alveoli and all of them have capillary on the surface, capillary plexus on the surface. So you see how beautifully everything is structured, microscopically, but beautifully. Okay? So all alveoli are covered by what? Covered by what? Capillary plexus. Is it clear? So this is the alveolus and you have capillary plexus around it, which is very important because we know that oxygen from the alveolus enters into the blood and carbon dioxide from the blood enters into the alveolus. So carbon dioxide from the blood enters into the alveolus and oxygen from the alveolus enters into the blood. Make sense? Now you tell me, if I ask you a simple question, why blood goes to the lung? To get oxygen. You all know that, right? So same thing, blood is getting what? Oxygen. And carbon dioxide, this is the rule. Carbon dioxide always moves in opposite direction. So oxygen from alveolus to the blood, carbon dioxide from the blood to the alveolus, opposite direction. Make sense? Everywhere, same rule. Okay, so that exchange inside the lung, in the alveoli of the lung, is called external respiration. Is it clear? External respiration, you can write it down in the lung, gas exchange in the lung. So this is also in the respiratory system because lung is in the respiratory system. Now what happens? After the blood gets oxygen, let's go back to cardiovascular system, you have already finished, right? Blood goes to the lung to get the oxygen. Now blood got the oxygen, gets back into the lung, right? Gets back from the lung to the heart. Which chamber of heart receives oxygenated blood? Left or right? Oxygenated. Always left. I said oxygenated, always left. Left atrium, right? And gives blood, oxygenated blood to the ventricle, left ventricle, and then left ventricle does what? Forcefully pumps the blood to the body. Remember that? So blood, oxygenated blood goes to the body. And in the tissue of the body, blood goes to do what? Get oxygen or give oxygen to the tissue? Give oxygen. You know that, right? Blood goes to the body to give oxygen to the tissue. So everybody knows it. Okay. So now it is no more in the respiratory system, right? Heart is pumping the oxygenated blood to the body. It is cardiovascular system, right? So that is the transport and internal respiration. Transported by the blood, you know that. Oxygen and carbon dioxide are transported by the blood, and in the tissue, what happens, you see, this is the body, tissue, these are the cells, okay, and the capillary. Okay, so this is the capillary in the tissue. So in the tissue, what happens? Oxygen goes to the tissue from the blood, and carbon dioxide always opposite, as I said you, from the tissue to the blood. Blood goes to the tissue to give oxygen, right? So blood is giving oxygen to the tissue and getting what? Carbon dioxide. So now you tell me, blood is giving the oxygen and getting the carbon dioxide. So blood becomes oxygenated or deoxygenated? Deoxygenated. Everybody? Getting carbon dioxide, right? And giving the oxygen out. So blood is getting deoxygenated. And that deoxygenated blood through the veins get back into the right side of the heart, right atrium. Make sense? So what happens in the tissue here, that is called the internal respiration. Just write it down. In the tissue. External in the lung, gas exchange in the lung. Internal is gas exchange in the tissue. And you already know what happens in the lung, what happens in the tissue. Why blood goes to the lung, why blood goes to the tissue, right? Blood goes to the lung to get what? Oxygen, right? And blood goes to the tissue to get or give oxygen? Give oxygen. That's it. Very simple. And carbon dioxide always in opposite direction. Okay? Good. So those are the 4 processes of respiration. Pharynx. After the nose, next organ is a pharynx, muscular tube, I have mentioned. It has 3 parts: nasopharynx, oropharynx, and laryngopharynx. Nasopharynx is nearest to the nose. That's why it is called naso. That's the first part, next to the nose. Oropharynx. Oro means what? Oral? Mouth. Mouth. So oropharynx is next to the mouth. Makes sense? Behind the mouth. And laryngopharynx is the last part. Why? Because it becomes larynx. It continues as larynx, the last part. So those are three parts of the pharynx. Now, here you see by three different colors. This is the nasal cavity, so this is the nasopharynx. This is oral cavity or mouth, so this part is called the oropharynx, and this is the laryngopharynx. Then this is the larynx and esophagus. So now, you tell me, if I ask you, this is nasopharynx, right? You put the food in the mouth and food goes this way, right? So this part is only for what? Air. Is it clear? But oropharynx and laryngopharynx are for what? Food as well as air. Make sense? So, last two parts, oro and laryngopharynx, are both for food and air. Is it clear? But naso is only for air. That's why the lining, inner epithelial lining, is different in those two different parts. Nasopharynx is only for air, right? So the chance of friction is very low. Is it clear? So that's why it is pseudostratified ciliated columnar. Oropharynx and laryngopharynx, food also passes through them. Food also passes through them. So friction occurs there. Is it clear? Friction occurs. Now you tell me from NP1, anybody remember I told you those areas you get a lot of friction. What kind of epithelial lining you have? A lot of friction, like esophagus, skin, you get a lot of friction, right? What kind of epithelial lining? Stratified squamous. Stratified squamous. Make sense? So those two parts, oro and laryngo, are not pseudostratified columnar, they are by stratified squamous epithelial lining. In the back of the nasopharynx, this is the pharyngeal tonsil. Pharyngeal tonsil attached to the nasopharynx, posterior wall of the nasopharynx. This is another tonsil close to the palate. You see the soft palate? This is called palatine tonsil. Makes sense because of their location. Nasopharynx, pharyngeal tonsil. Near the palate, palatine tonsil. Right? And this is the tongue. So in the back of the tongue, you see here, there is another tonsil. That is called lingual tonsil. So three tonsils, right? Pharyngeal. Another is what? Near the palate. Palatine. Palatine. Its name is, after the structure. In the pharynx, you have pharyngeal. Close to the palate, you have palatine. And in the back of the tongue, lingual. Lingual means what? Tongue. Lingual. Tongue. Linguistic. Okay? Okay. Is it difficult? No? Just you have to remember, right? Okay. So tonsils. Pharyngeal tonsil is also called adenoid. Adenoid. Have you heard that? So adenoidectomy is what? Surgical removal of which tonsil? pharyngeal tonsil. Make sense? Because adenoid is another name of pharyngeal tonsil, right? So removal of adenoid or pharyngeal tonsil is adenoidectomy. If you hear the term, it is a little bit different. Adenectomy. This is different than adenoidectomy. Adenectomy is removal of any gland or part of any gland of the body. Okay, so this is more common, wide. Anyway, so those are three parts of the pharynx. Now one thing here, look at this, this is important. From the lower end of laryngopharynx, you get two tubes. One in the front, that is the larynx, part of the respiratory system. So air, this is very important. Air and food both passes through this part, right? But air will only enter into this tube, larynx, and food will only enter into this tube, which is what? Esophagus. So larynx in the front, esophagus in the back. Is it clear? So if food enters into the larynx, what will happen? Yeah, it will go to the trachea and inside the lung, right? That would be dangerous, can kill the person. Should not occur. You know, even a small piece of food, if it enters there, you feel that, strong choke. Okay. So here, the food and air get separated. That's why there is a cap here. This is called the epiglottis. You see this structure called what? Epiglottis. This one is like a cap. Moves like this. When you swallow the food, this should be open or closed? Closed, because this is respiratory, right? This should get open, esophagus, for food, right? So, when you swallow the food, the epiglottis moves down to cover the entrance of the larynx. Is it clear? So, laryngeal inlet will be covered, capped, like this, okay? When you swallow the food, because food should only go to the esophagus, okay? So very important. When you breathe, it should stay open. Okay, now let's see. This is the epiglottis. Let's quickly go over. Okay, so inside the nasal cavity, you have those structures are called concha, superior, middle, inferior, right? Separated by what? Metatarsus. Superior, middle, inferior metatarsus. Okay, in between concha. And the concha, I didn't mention that. These extended structures inside the nasal cavity, they help the air turbulence of inspired air. When you inhale the air, it will, move like this. So that will mix the air, will allow the air to get contact to the, the mucosal light, to get warm and moist. Larynx, I said larynx is a cartilaginous tube, which is also called voice box. Okay, now there are two types of cartilages in the larynx. Some cartilages are single, only one, and some are paired, same but two in number. Is it clear? So paired and unpaired cartilages. Let's first see the largest cartilage. Largest cartilage of larynx is the thyroid cartilage. Which one is thyroid cartilage? Anybody? Adam's apple. What is Adam's apple? Right, this one, right? So that is the thyroid cartilage. And this cartilage, it's very interesting. Is sensitive to male sex hormone. Sensitive to what? Testosterone. And that's why, you know, when the kids at puberty, boys, they get the laryngeal prominence, Adam's apple, clear. In early stage, you don't see that. When the testosterone secretion occurs, that stimulates the growth of the thyroid cartilage. This is interesting, right? Okay. That's the one and largest. Second largest is called the cricoid cartilage. This one is also unpaired, single. Now, paired cartilages are arytenoid, cuneiform, and corniculate. Those are 2 in number. Each has 2 in number. Arytenoid, corniculate, and cuneiform. And